you.
Thank you.
Thank you all. Bye. Have a nice lunch.
Welcome back. We now hand over the session to Mr. Niranjan Toraskar. He is the session chairman to make further announcements. And one more request that before the tea time, we will again try clicking more pictures. So kindly switch on your video mode. Yeah. So enjoy the session and over to Mr. Toraskar.
Hello, good afternoon. Welcome back after the lunch session. The first paper is put the paper, Samita. Yeah. First paper is by Mr. Christian Kleeberg. Is a managing partner and founder of Argio Asia Private Limited. About the author, an APAC joint venture with the Argio GmbH company in Dortmund, Germany, the leading provider of digital transformation solutions for the metal casting foundries in Central Europe with more than 320 plus installations under its belt. Christian brings along more than 20 years of experience in digital software application for the metal casting operations and has profound knowledge in digital transformation applications, including IoT for foundries. The, the heading of the topic is Digital is the New Normal, 10 misconceptions when it comes to digitalization of the metal casting operations. Mr. Christian Kleeberg is also associated with ALUCAST for a long time and he has also presented papers in previous ALUCAST. So I hand over to it to Mr. Christian Kleeberg.
Hello and good afternoon. Am I audible?
Yeah.
Okay, very good, very good. Yeah, excellent. Good afternoon, ladies and gentlemen. It's my pleasure to be again with ALUCAST, this time on a virtual conference. And please allow me not to use my video because we have a lot of rainstorm here in Singapore and it is very thundery outside. So if you hear some background noise, apologize that. And sometimes some flash comes in and that would disturb the video as well. Yeah, please let me share my screen. And I'll do the needful. I hope everybody had a good lunch. My screen is visible, yeah?
Yeah.
Excellent. All right. And I go into full presentation mode. Yeah. Today, the topic of digitalization in ALUCAST 2020 is about 10 misconceptions in metal casting operations. And let me minimize here this one as well. So I want to talk about what can go wrong when you talk about digitalization. What can go wrong in order to find out how to start making the operations digital. This is, by the way, the third time with ALUCAST, or actually the third time since 27. The fourth time with ALUCAST since 27. We talk about digitalization. In 2017, we talked about die casting 4.0. In 2018, we talked about digitalization of the operations. In 2019, we talked about data collection concept that was in Pune. Yeah, and today we talk about project failures. What can go wrong when you want to digitalize operations? Small introduction first, a little bit walk down memory lane. We talk about the 10 misconceptions per se. At the end comes the $1 million questions, followed by the SFRI and our recommendations. Quick introduction about our company one more time for those who have not heard about us. Argio Germany is founded in 1984 by foundry experts with profound IT knowledge. And we have today about 85 specialized employees in the foundry industry. We have a lot of projects and customers under our belt. In APAC, we are running the show since January 2017, and we are proud to say that we're operating directly in India since October 2019 via Foundry Resource Planning and consulting. Yeah, a little bit about our company one more time. We understand ourselves foremost as consultants who have a full, strong partnership for process optimization. We have, of course, software to support that, and we have IT knowledge and IT understanding and IT solutions. And at the core of our IT solution is a production planning and controlling technology as a functioning as a manufacturing execution system. And we are having a so-called digital twin approach. And this digital twin allows us to digitally replicate the manufacturing process. We hope we speak the customer's language, and we believe that software plus good consulting is the success for our client. Let me quickly come down to the historical area because we are talking about digital. When we look back a couple of years in the 60s, 70s, we talked about labor-intensive ages and skill-intensive ages. Then in the 80s and 90s, we talked about capital-intensive age, and in the 90s, very much technology-intensive age. Who remembers the dot-com bubble at that time? Then came the zeros right after the millennium change, knowledge-intensive age. And then the 2010 onwards, innovation. We talked a lot about innovation in the last 10 years. Now the 20s have started already, and more is a discussion about digitalization. And it seems to be that the next 10, maybe more years, this digitalization move is even more on the horizon, and there will be more discussion about how to go about it. And we, as a supplier, of course, we see emerging technologies bringing in new perspectives, and we see very much sustainable growth in areas where innovation and digitalization prevails. The COVID situation has not touched anybody who is fully digital. And then I was just talking yesterday in another conference on Industry 4.0 for the Foundry. We also had a lot of discussion there about the way on how digitalization can help to have sustainable growth. Yeah, Foundry 4.0, innovation via digitalization. What's that? Why should I do it? And how do I do it? When and where do I start? And what misconceptions actually prevail? And what are the things you are not supposed to do? And these are actually very burning questions right now, which a lot of companies, especially also the aluminium die casting sector, are asking. And we have a couple of consulting projects right now happening with clients in India who want to understand better and who want to understand more how to go about it. As such, our aim is that we are looking into not only the aluminium industry, of course, we are also looking into the steel and iron industry, and it's bringing about digital solution in this heavy industry area, of course, casting, forging, steel mill, ALUCAST, and smelters. And how can we bring new technologies and can integrate them? That is the most important part. Integrate them in an environment which can be at times challenging. So, having said that, let me just have a side scenario. We have a very special solution that is available just for the iron and steel industry, not related to aluminium. But it's important to understand, even in the most difficult environment, like a melt shop, we are able to digitally enhance areas. And when we can do that, the rest can be managed as well. Let us come to the 10 misconceptions now. And this is very, very important. Please listen up. The very first one is management initiation of a digitalization project. Digitalization of digital transformation is a feat of strength and requires profound change. Therefore, the management team must also be prepared to fundamentally change their attitude. When a project affects several areas of the organization, directly impacting staff and practices, the role of the management board is not just to initiate the process, no, and approve budgets and sign contracts, no. But in practice, however, this is often how leaders see their own role. For the full duration of a digitalization project, the management team has to be a point of contact of the staff, trust those responsible for the project, and equip them with the necessary decision-making authority to ensure that the project runs smoothly. Only then will the change be successful throughout the entire organization. Number two, All love modern solutions. Not all can live up to it. During a change process, employees can become demotivated if they lose faith or fail to understand the ultimate goal. For many, the first reaction is to resist change. Who doesn't know about that? Some employees fear for their jobs. We have to take that away. Others are afraid of losing influence because of they no longer have maybe a information monopoly. And for others, it is the fear that their work will now be more closely controlled. For everyone involved, such projects mean more work. The data transparency involved will result in a higher employee transparency. Certain businesses are used to that. Others are not. And in metal casting, many even say the foundry is a black hole, where something comes out after putting something in, but nobody really knows why and how this happens and how much it precisely costs. Corporate management must recognize these fears and from the word go, provide targeted information. Why the new system is necessary, why working methods need to be changed, how the individual staff members can benefit from it, and many, many, many more. Number 3, digitalization. The IT guy can take care of it. The topic of digitalization is often placed in the hands of the IT guys. But as said before, digitalization is not an IT project. When choosing a suitable project manager, it is not only IT skills that are required. On the contrary, soft skills such as communication, empathy, credibility are more important than technical skills. When it comes to extensive digitalization and the selection of the right change agents, we have to make sure we understand the dynamics. Number 4, think big. Let's optimize everything in one shot. Probably the worst thing to do. And an efficient and productive workflow only emerges when cross-departmental processes are well coordinated. That is why digitalization and digital transformation strategy should be implemented across the board. However, this does not mean that you have to digitalize everything all at once and cannot initially concentrate on specific areas. On the contrary, it makes more sense to focus on key processes than can do simply start in all departments. Over a period of time, you will see that when you go small, go departmental wise, and you are in a position to expand from there, the success comes by itself. Trial and error is the way to go. Number 5, digitalization and digital transformation in metal casting operations is not an end in itself, but means far-reaching investments that generate concrete added value, whether through higher sales and profits or through new customers. The failure and the resulting impact on employees as well as customers and partners must not be an option. In practice, there are countless examples of digitalization projects that were pursued over many years and in the end had to be scrapped. Certainly a setback that not many companies could survive unscathed. The shop floor doesn't need it. Number 6, a lot of people are discussing this right now with us. In metal casting operations, transparency is the key to success. Digital solutions and digital transformation concepts contribute for this. Now, in order to achieve any type of transparency, you must collect data. This data must come, among others, from the predominant source where the data is created, and that's the shop floor. Many metal casting operations, however, neglect the shop floor data source, thinking they don't need it in terms of feedback and in return of cutting off vital information for operational excellence. This is more addressing the SMEs. Big data is only for big companies. When it comes to the concept of harvesting a company's biggest asset, it's manufacturing data, and especially SMEs or even micro SMEs, when they are moving into the direction of very important misconception that has been seen in the past. The perception is that big data involves big company is outright wrong. The reality, however, is quite different, and the actual contrary is the true reality. Any metal casting operation of any size, be it the 20-man mom and pop hand molding show, or be it the 3,500 employee, 1,000 tons a day automotive mass producing casting operation, both produce big data. Maybe the latter one slightly more than the other one, but in quality and quantity of what you need to harvest the same, there is no difference. Digitalization in metal casting operation means always big data. And this big data represents, of course, big money too. So a management team should define here the type of data they require, in what format, and whether it's in real time or not. Then you will see very quickly what it means when big data is involved. We have ERP, means we are digital. Well, that's a classic one. It requires almost no further comments. Still, many metal casting operations haven't understood that having an ERP system means you merely administrate your data flow, many times only in finance. So what about operations, planning, controlling, WIP reporting, rolling shop floor inventory, consumables, etc.? The list is endless. If MS Excel prevails in any of these, and in many companies that's the case, unfortunately, then you are not digital at all. The digital transformation team must point out the area where, for example, MS Excel prevails and where it is designed to be eliminated via integrated system, real-time or on-time data collection, and steady visualization using dashboards and other means. Almost the last one, number 9. Foundry is 3D, dirty, dangerous, and difficult. Let's outsource. Image of the industry, legacy issues galore, lack of adequate workplace design. Do we need to say more? The foundry is perceived to be indeed 3D, dirty, dangerous, and difficult, but foundry can also be very much D3, digital, dynamic, different. Remember, we can't change the process as such, as metal has to be molten into a liquid and poured under various process conditions into a mold of any kind. The shaping process itself is maybe sometimes 3D, but the planning, controlling, and data collection visualization process can be very much D3. Here, digitalization must be monitored, especially in order to lift up the image of the industry. And digital transformation means automatically productivity and image improvements. Some companies will then rather outsource than doing it yourself. As such, that's an opportunity for those who are committed to the process and to the full understanding of benefits this process brings along. Yeah, and as a last one, digitalization and digital transformation is not for me. Well, probably that is the most severe misconception we have come across in the last years. And I hope COVID-19 has shown to many of you that actually it's the opposite. Digitalization is for you very much. Who can work with 50% of their workforce at home? Many people are not prepared for that. We have a lot of clients who we are consulting right now, especially in that area. So how many times have we heard this? Probably way too often. Despite Industry 4.0 movement and many other initiatives, the metal casting industry has yet to discover the great potential digitalization and digital transformation entails. And one more time, it is very important that here we are looking into something that entails the whole organization, not only the management itself or the IT guy or relevant people. It comes down to the million-dollar question. How much does it cost to digitalize? How much does it cost to make things digitally in an operation that is very difficult at times? Actually, it's not a matter of the price we are looking at. It's a matter of, can we afford not to do it? And that's actually the idea we are giving across, and we want to make sure that also in ALUCAST 2020, people understand. Start small, initiate a project, see what you can do. Even if it's an IoT reader device, excellent. If it costs a little bit of money, fantastic. But go step by step, because you can't not afford not to do it. More and more the industry, the customers are asking for transparency of the operations, the automotive especially. And that means automatically you have to invest into this area, and you have to look into where are we not digitally controlling things? Where are we still with paper and pencil, Excel sheets if we are lucky, and log sheets? Here are our 10 tips to start. We call it Foundry 4.0 at your own leisure. First of all, don't jump into buying expensive solutions first. Know your people's skill set and limitations. Know your current SOP level. How many do you have? Break down into smaller segments, for example, by department. Simplify and standardize before digitize. Ensure clear linkage between tasks and accountability. Start with smaller section for a pilot run. Learn from first success cases. Look for good collaboration partners. Very, very important. Ultimately, buying software means nothing without support. And at the very, very end, again, probably the most important item, have a digital mindset to be successful. That is so important. Otherwise, people will still walking around with log sheets, with paper and pencil, or if we are lucky, an Excel file. Yeah, you can contact us under these contact addresses, fapconsulting.in in India, rguasia.com. We have lots of publications right now. Also, this publication is available also on LinkedIn. Please follow us. Last but not least, for us, the industry is important. We don't want them to fail. That's why let's go digital. Thank you very much.
Christian, your lecture is over?
My lecture is finished, yes.
Oh, it's a short time. We have got enough time now here.
Yeah, then we have maybe
Yeah.
some discussion. Unless if not, then what we can do is we can also put the question and answers at the very end.
Yeah, yes. I will request people. Thanks for the nice presentation and about the misconcept going digital. They're really informative. Now I will see that some questions are there. Till now, no question is there. So I think,
Yeah, we can just move on. That's not a problem.
yeah. Okay, then. Thanks, Christian. We'll move on to the next paper. Samida? Mr. Shende, hello. He's there. So shall we start for the next paper? Okay. The next paper is given by Mr. Praful Shende, is the Chief Sales and Marketing Officer of Bharat Fritz Werner Limited. Mr. Shende is MTech from IIT Madras and has an experience of more than 35 years in projects, operations, and managing a business unit like Kena Metal, Vigil Manufacturing Technologies, etc. For the last 8 years, he is associated with the BFW as the Chief Sales and Marketing Officer, also associated with the IMTMA EC committee. Now, the topic of today's lecture is BFW High-Speed Machining Solutions for Aluminium and Die Casting segment. Okay, so post-operation of the casting operations, the machining is always required, and many customers, they ask for the machine casting, not only the fatal casting. So let's see how this high-speed machining helps to the making the post-casting operations. Over to Mr. Praful.
Good afternoon. Am I audible?
Yeah, clear.
Right. Okay. So thank you first of all for giving this opportunity to be a part of ALUCAST. BFW per se has been with partnering with ALUCAST for almost recent all of the annual events of ALUCAST, and we consider the entire aluminium manufacturing industry as an important segment to partner with. So thank you from on behalf of BFW for giving this opportunity. Before we start, and then we will move to the topic. Can I share my screen?
Yeah.
Is it?
No, it's not
Is the
visible.
video visible?
No.
It's not visible.
Just a blank sheet is there.
One moment.
Yeah.
Well, if I share it, it is showing it is paused. Is it visible?
No, not yet. Rishikesh, can you help him out, please? Our IT
Yes,
guy.
sir. Can you please try to share again?
Is it visible?
Yeah, now it's visible.
Let me start from beginning. Yeah.
Yeah. Can you increase the background noise, this thing music and
Mr. Shende, if you would just go to the bottom left and see in case if you have muted.
Is it visible?
Yeah, now it's visible, but we do not have the
Voice.
sound playing. So just check your laptop anywhere, wherever there is a
It's
sign.
only the music, so it doesn't matter really. It's just the
Okay,
music.
No
so there's
problem.
no voiceover. Okay, sure.
Yeah. Thank you. So we do many other things, and of course we make machines too. So while now I start my presentation on integrated solutions for manufacturing of aluminium. Yeah, is my screen visible?
Yeah, it's visible now.
Yeah, okay. Am I audible too? That's
Yes.
good. Yeah. So I'm going to talk today on the integrated solutions, manufacturing solutions for focused on aluminium. Let's look at the entire manufacturing operations gamut. So for manufacturing, you actually have to look at solutions. So what we continue to do is we are not here really to make the steel, process steel in form of a machine and supply to the customers. So what we do is we try to look at solutions. And that means you need product technologies, you need manufacturing lines, production lines. We do these solutions on 3 pillars based on technology, process, and people, of course. And the solutions related to machines we bring from BFW, and our 100% subsidiary M2 Next brings the solutions related to automation, digitalization, and process engineering. Today, I'm going to focus on the product technology, the machining side of it. Yesterday, my colleague Jagannath, I think, spoke about the entire digitalization aspect.
Yeah.
We present, of course, in globally and about 48 locations in India. Aluminium is the heart of is at the heart of manufacturing, and the drivers, of course, the segments in which aluminium is very increasingly getting used is automotive, building constructions, electronics, especially the Indian side. These three are growing rapidly. And of course, aerospace and defense would be one more area where aluminium is finding increasing presence. I don't have to go into the details. You know this much better than me, that the die casting and automotive side, the percentage of aluminium in automotive is increasing, driven by EV emission norms, fuel efficiency, lightweighting, and also the electronic side with the great push from Government of India on Atmanirbhar Bharat. We are seeing a great penetration in terms of manufacturing of telecom equipments, electronics, and this will grow significantly. And I think that will create enough opportunities for all of us who are into the aluminium manufacturing. And the segment, of course, is in die casting and machining. That's the total value chain. And both the areas need to be efficient, both the areas need to be smart, and both the areas need to be digital. What do you need for the machining side? Aluminium itself presents a lot of challenges. The machining rates are very fast. Idle times on the machine play a lot of role. The composition of machining times to idle times is very high. That means machining times are low and idle times are high. And therefore, the product technologies need to be state of the art. You need higher rapids, you need good accelerations, you need very low tool change times, you need high acceleration spindles, and you need faster machining to be able to exploit the diamond cutting tools. You need very properly tuned power torque diagrams. You need good base speeds, and of course, last but not the least, you need outstanding chip management. From the productivity side, this is what you would need. And then the footprints need to be smaller. Operators normally operate multiple machines, so the walking distances have to be less. In case it is an automated solution, the compactness further brings the competitiveness along with it, and therefore the compact footprints are the next side of the requirement. And accuracy, of course, is the foundation. You need outstanding thermal stabilities of the machine. Typically, in our context of tropical conditions, you need good repeatabilities, robust spindles, and good part cooling feasibilities. So there are three circles: productivity, footprint, accuracy, and at the cross section of it, the products need to be. So BFW, we are committed to innovation, and to foster the innovation, we have a Kalam Center of Innovation where we bring out the product technologies as well as the cutting edge technologies related to the product. So whether these are horizontal machines, whether these are vertical machines, and whether they are turning machines. So on all the three sides, you need those three pillars of productivity, precision, and smallest footprints. And all those features form the bedrock of the product developments. At one time, high-speed machines were considered to be high technology machines in India, and therefore large amount of these machines were getting imported. Today, these technologies are now available in India, and many of the customers, many of you who are present even today here, are exploiting these Indian technologies, which are comparable or in some cases better than the imported technologies. Machines with, so here is the smallest product, this is less than a meter in width. This is just 999. So in terms of the technology, miniaturization is the key. Without compromising anything on rigidity, without compromising anything on the operator access, the miniature. So our smallest product here, which is on the Mac platform, starts from a meter. And you can see that such machines, when they are stacked together, can greatly enhance the productive use of the shop floors. You need rapid rates. You need rates of, let's say, 60 meters per minute. You need great accelerations, 1G, upwards of 1G. And you need outstanding spindle accelerations and chip-to-chip times to the tune of about 1.5, 1.6 seconds. Again, this chip-to-chip time technology at one time was a domain of, considered to be a domain of high technology, and but with the outstanding Indian talent available within the country, engineering expertise, these technologies are now available within India, and comparable products are available. For example, our Dhruva platform and Omega platform, the smallest chip times are possible like this. What we do is a great thrust is laid on the analysis of at the design stage, whether it is a static analysis of structures, whether it's the speed. For speed, you need optimum combination of rigidity and agility. For agility, the rigidity and the weight has to be very properly controlled, and therefore the analysis packages used for static, dynamic, and thermal stability, they result in very optimum single piece, most of the cases single piece structures, which can provide such features of combination of speed and rigidity. Most important, as I said, are the chip disposal issues. Reliability of the machine is important, and therefore it is important that, and aluminium is a very tricky material in terms of chip disposal. The chips fly everywhere, and a common thing that we run on most of our platforms is we isolate the complete machining machine elements from the chip zone. So the machine is completely isolated from the chip zone, and therefore the reliability, the maintainability, and the longevity and the accuracies of the machines stay stable and stay at a very high level, because the chip zone has been completely isolated. And then you can produce, you can of course give a large amount of coolant, heavy sprays and such things to see that the chips are disposed, machine stays free of chips, and the components which come out are totally clean. Today, you would also need the machines which are flexible. The types of components are changing very rapidly, and to protect your investments, it is important that the lines that you set up are flexible. You should be able to have different features to be added onto the machine. For example, some components may need rotary tables, some components may need tilting rotary tables, pallet changes, and on the same platform, you should be able to incorporate all these things by making changes on the machines very quickly. You should be able to reconfigure the lines for different products. So such aspects have been considered at the engineering stage, and that allows your investment to stay flexible in today's world of very small and short product cycle times. Let me come to the precision side of it. India, as I said, is a tropical country. The temperatures vary in the north side from about 4-5 degrees in winters to about 40-50 degrees in summer. It has unique challenges. The challenges normally are not encountered in stable atmosphere nations outside. So the product designs, what we do, take care of a very good thermal stability. And that is done by cooling various elements in the machine. Most of the platforms, every heat element is cooled. For example, here you can see the ball screws are cooled. The ball screw is cooled. On the structure there are coolant jets. Spindle is cooled, and the fourth element, which is the axis servo motors, the joints between the servo motors and ball screw are cooled. What we do is very advanced algorithms we have developed to see that by measuring what is the heat that is getting generated during cutting and the heat that is getting generated due to changes in atmosphere temperature, those are compensated in real time. And this technology which we are bringing out in 2021 beginning is called Intelligent Real-Time Thermal Stability Control. It's one of the first of its kind technologies which will come on the Indian machines to see that the machines stay totally stable despite the thermal variations in the atmosphere. And then you get outstanding accuracies. Normally, the accuracies, typically the precision, the repeatability and the positioning accuracies of CNC machines are measured on a ISO standard, ISO 230-2. BFW platforms have BFW standards of accuracies, which are about 50% of ISO accuracies. So certain platforms, they are built with enough care in manufacturing and enough care in assembly processes to get to 50% of standard ISO accuracies, which allows you to maintain your process capabilities to much higher levels that you would look for. And today, your components are getting more and more accurate. The component accuracies are getting stringent, and with lightweighting becoming a norm, electric vehicles coming in, the components are only going to get more complex and more accurate. For example, the circular accuracies are to the range of about 3-4 microns on some of the products. And when you take such products and put them onto the technologies, we partner with the customers to see that the entire process is built. We're not here, again, I'm repeating, to say that here is the machine and you do what you want to do with the machine. No, that's not what we do. We try to look at what you want to do with the machine, and our process engineering team works with you to see how can we make this component shed better, shed more competitive, when you actually start producing. So what we talk really are cycle times, what we talk is really the takt times, and what we talk are cost per piece. Typically, you lay out the lines. Lines could be manually attended, lines could be automated, there could be gantry, there could be robotics, and all these integrated solutions, the solutions are available. It's good to engage at the engineering stage and work out the bigger picture of the total production, and uh, sometimes it can happen that the production scales up, and once the complete picture, the total bigger picture is available, the investments can be staged, investments can be scaled, and then lines can get expanded as and when they go. Here what I'm showing to you is a typical line for the component what I showed, this particular component, which is, any component which are 100 by 100 size. These machines are very small, about 1 meter machines, and uh, typically normally it takes about 12-13 meters of space, and this is about 8.5 meters on these machines. So you have about 20-25% of significant reduction on shop floor space. This is another example again for stacking the machines together, connecting them onto the conveyors, connecting them with the robots, connecting them with the cobos. We partner with Universal Robots, and we also offer solutions based on collaborative robots. These are some of the examples of the lines that we have set up at some of your shop floors for aluminum manufacturing. So you can see this particular picture. I have a lot of videos, but I'm avoiding to show videos here because of the bandwidth issues. But this is a typical line put within India, which is multiple machines operated by a single operator. Conveyors, they could be power conveyors, they could be manual conveyors. All the machines completely TPM friendly, and a fully integrated solution implementation, so that you all have to be busy looking at how to make the components, rather than going behind one vendor for machine, one vendor for conveyor, one vendor for robotics, one vendor for tooling, and some other vendor for fixtures. So project management becomes a significant issue in such cases when you're setting up such production lines. Single source responsibility is what we talk, and project management is our strength. So we are here to participate, we are here to talk about such solutions. This is another example of fully robotized machines for the crankshaft manufacturing. This is of course not an aluminum component. And there's another example of fully robotized solutions. I would rather keep more time for the discussion and questions if there are any. What I'm trying to say is, let's start thinking solutions. Let's start integrating the manufacturing, and let's start looking at competitive manufacturing solutions so that we can start addressing together global needs of aluminum machining. Thank you.
Thank you very much, Mr. Shende, for a nice presentation and telling about your new machine, which has got many features with the space, space-saving features and other accuracy and other automation, total automation this thing you can give. So very good, and it is very informative for our diecasters. Now, any questions are there? There are no questions till now.
Okay.
Okay, thank you. The people must have learned everything about your machine.
Yeah. Yeah, sure.
Thanks a lot.
Right.
Now I hand over to Samida for the next thing.
Yeah, so we we look scheduled for an early tea time, looks like.
Yeah.
I would request everyone to switch on their video mode. Rishikesh would like to take some pictures. So all delegates, presenters, and all those attending the conference and helping out, session chairmen, kindly switch on your video for a few seconds. So I think Rishikesh has a good number of delegates in the picture now. So Rishikesh, are you good? Rishikesh?
Yes, ma'am.
Okay.
Thank you.
Thank you. And we break for an early tea and see you in another
I
15
have a short request to make to all our participants. Those organizations where you are projecting this program live to your office people, kindly send the photographs to Mrs. Veena Madam so that we can take it up for publication in our next ALUCAST journal. Thank you.
Thank you. So see you in another 15 minutes.
So what time? Just till the time, not 15 minutes.
3 o'clock, 5 minutes. 3:10, sorry, 3:10, because we are at 2:55, so 3:10.